So let's talk about the definition now of vertical asymptote using calculus, right? So in the previous video, we talked about computing limits, where when we plug in, we get that determinant form, a non-zero number over 0, and we know that it's not going to exist, right? But now we talked about how we can figure out, is it infinity, is it negative infinity, or is it just does not exist, right? And so we did that by considering the left-handed and right-handed limits. So here it's asking me, is x equal to 5 a vertical asymptote of the function f of x? Alright, so of course using pre-calculus you could try to figure this out, right? By making sure it's simplified, setting your denominator equal to 0 and solving for x, and you would get those asymptotes. But how would I do this using calculus, right? So we need to look at the formal definition. It says the line x equals a is a vertical asymptote of the function if either the limit as x approaches a from the left of f of x is equal to plus or minus infinity, or the limit as x approaches a from the right of f of x is equal to plus or minus infinity. Okay, so basically if I want to figure out if at x equals 5 there's a vertical asymptote, I need to consider the limit as x approaches 5 from the left of the function and the limit as x approaches 5 from the right of the function. And if for one of them I get some form of infinity, I know that there's a vertical asymptote there. So let's consider them. So let's look at the limit as x approaches 5 from the left of this function. And so remember, you want to use the factored form. So this is going to give me x minus 5 and then x plus 2. Okay, and so we know that if we plug in 5 into this function, that I'm going to get 5 over 0, right? So hopefully we can see that. Okay, if not, you need to just do it off on the side. There, plug in 5 and you will see that you'll get 5 over 0, right? So what we need to do is we need to do what we were doing in the previous video, right? We need to figure out, is it going to be positive infinity or negative infinity? And we need to pick a value that's really close to 5, but to the left of 5 on the number line. So 4.9, right, will be a number that's really close to 5, but to the left of 5 on the number line. So here, I'm going to do some side work, and I'm going to plug in 4.9 into the function. Okay, and then you remember, right, that I don't actually really care what these numbers are. I'm just looking to see that the top is positive, and the bottom is negative times a positive, right? So this will give me a positive still in the numerator, but then a negative times a positive is a negative, and then a positive divided by a negative is a negative. So this is a negative number. Okay, so I know that it's going to negative infinity. Okay, and so we should check also the right-handed limit as well. But at this stage, if you just show me that the left-handed limit is some form of infinity, this is enough to justify that x equals 5 is in fact a vertical asymptote. Okay, but just for the sake of doing, getting more practice with this, why don't we just do the limit as x approaches 5 from the right? Okay. Okay, and so we already know, right, that this is going to be 5 over 0. So now I want to pick a number that's close to 5, but to the right of 5 on the number line. So like 5.1, for example, right? That's close to 5, but to the right of 5 on the number line. So now when I plug in, I get 5.1 over 5.1 minus 5 times 5.1 plus 2. And I know that all of these numbers here are positive. So of course here, this is going to give me a positive number. So this is positive infinity. Okay, and so by definition, of a vertical asymptote, we have that x equals 5 is a vertical asymptote. Of the function f.